Hello everyone. In this video we are going to discuss another example from practical number 3. We have given three graphs and we want to draw planar representation of these three graphs, as well as they have asked to verify Euler theorem for each graph. So I am calling this graph as G, and here I am drawing planar representation of G. Planar representation of G. What is planar graph? A graph is planar if any two edges do not intersect in the interior. Planar representation of G. So we have A, B, C, D, E and O. These are 6 vertices. So first I am here drawing O, vertex O, and joining this vertex O to A, B, C, D and E, because O is, this vertex O is adjacent to all these vertices A, B, C, D and E. So O, A, B, C, D and E. Now O is adjacent to A, B, C, D, E. Let us see A is adjacent to. A is adjacent to B and E. So A is adjacent to B and A is adjacent to E. B is adjacent to O and O, A and C. So BO edge is drawn, BA edge is drawn. So B and C. C is adjacent to O, D and B. CO and CB edges are drawn, so only CDs remain. D is adjacent to, where is D? D is adjacent to, this vertex D is adjacent to C, O and E, out of which DO and DC are drawn. Only D was remaining and I have drawn that D also. So you can observe any two edges are not intersecting in the interior. So this is a planar representation of graph G. We have to verify the Euler's theorem. For that we have to count number of vertices. What is Euler theorem? Euler theorem is, for any simple planar connected graph, P minus Q plus R is equal to 2. So let us count number of vertices, that is P in this graph. Number of vertices 1, 2, 3, 4, 5, 6 vertices. How many edges are there in this graph? This is first, second, third, fourth, 5, 6, 7, 8, 9 and 10. Number of edges 10, and number of regions 1, 2, 3, 4, 5 and last region is infinite region, that is 6. So consider P minus Q plus R. P minus Q plus R is equal to 6 minus 10 plus 6. 6 minus 10 minus 4 plus 6 is 2. So P minus Q plus R is 2. Therefore Euler's theorem is verified. Euler's theorem is verified. Now let us draw planar representation of another graph. Suppose this is our graph G, and here I am drawing planar representation of graph G. Planar representation of G. You may draw another representation. It is not necessary that this planar representation is unique. You may draw a planar representation of graph G in another way also. So here if you count degree of A, 1, 2, 3, 4, degree of, this is simple graph, so I am not counting degree. So planar representation, let us draw A, B, D, C, G, H, G H F E I and J. So only two vertices are remaining, I and J. So I have drawn them outside this graph. I is adjacent to A and D, and B is adjacent to, J is adjacent to B and C. Also there is an edge between I and J. So I am drawing this edge. So you can easily observe that any two edges are not intersecting. So this is planar representation of our graph G. So let us count number of vertices here. So here number of vertices is equal to P. Number of vertices is equal to P. Number of edges is equal to Q. And number of faces or number of regions is equal to R is equal to. So number of vertices 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number of vertices 10. Number of edges I am counting here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. Number of regions. So I am counting number of regions. This is R1, R2, R3, R4, R5, R6 and R7, and this is infinite region R8. So there are 8 regions. So let us count regions again. R1, R2, R3, R4, R5, R6, R8 and this is R9. I forgot to count this region. So number of regions is equal to 9. So consider P minus Q plus R, that is 10 minus 17 plus 9 equal to 10 minus 17 minus 7 plus 9 is equal to 2. That is P minus Q plus R is equal to 2. Therefore, Euler's theorem is verified. Let us draw planar representation of this graph. This graph is G. Here degree of A is 1, 2, 3, 4, 5 and degree of D is 1, 2, 3, 4, 5. So first I am drawing A and joining all the 5 vertices adjacent to A. So adjacent vertices to A are B, C, D, E, F. That means all are adjacent. B, B, C, D, not D. I am not drawing D here. Except D vertices adjacent to A. I am drawing those vertices B, C, F and E. Now I am drawing here D. So D is adjacent to C. So I am joining here C to D. Then D is adjacent to E. D is adjacent to F. And D is adjacent to B. Also there is an edge between A and D. So I have drawn AD. Now see, vertices adjacent to B are BA, BD, BC. So BA, BD are drawn, only BC is remaining. Vertices adjacent to C are BD, F. B, D, A and F. So B is adjacent to C, A, D. So only F is remaining. So I have drawn edge between C and F. Vertices adjacent to F are A, C, D, E. A, C, D, E. AC is drawn. FC is drawn, FA is drawn, FD is drawn, FE. So I have drawn all the edges. Let us check again whether we have drawn complete graph or not. Here A has 5, degree 5, B has 3, C has 1, 2, 3, 4, D has 5, A has 3 and F has 4. So A has degree 1, 2, 3, 4, 5. B has degree 1, 2, 3, C has 4, F has 4, E has 4 and D has 5. So we have drawn complete graph. Complete means entire graph. Planar representation of G. Now let us count number of vertices, edges and regions of graph G. So number of vertices in G, number of vertices is equal to P is equal to 1, 2, 3, 4, 5, 6. Number of edges in G, number of edges, vertices in G, number of edges in G is equal to Q and number of faces in G is equal to R is equal to. So I am counting number of edges 1, 2, 3, 4 or it is easy to count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here there are 12 edges in graph G. Now let us count number of regions. This is R1 infinite region, R2, R3, R4, R5, R6, R7 and R8. So number of regions 8. Now consider P minus Q plus R. Consider P minus Q plus R, that is 6 minus 12 plus 8, that is minus 6 plus 8, that is nothing but 2. So P minus Q plus R is equal to 2. That will imply Euler's theorem is verified. Euler's theorem is verified. So we have drawn planar representation of all the three graphs and verified that Euler theory and show that Euler theorem is verified for all these three graphs. So in our next video we are going to discuss another example. Thank you.